All right, I've got this. You get the best title for your talk. All right, Blair Wilcox, Hot Rocks. Did I get that right? All right, Hot Rocks.
Thank you. As mentioned, I'm going to talk about hot rocks and how when a toaster and a brick really, really love each other, they can decarbonize process heating and provide support for renewable electricity on the grid. So what are our targets here? Our targets are big steam production boilers in industrial sites. These industrial boilers use a tremendous amount of heat, tremendous amount of natural gas, and release a bunch of greenhouse gases. But these are ubiquitous. As you can see, 23% of the US greenhouse gas emissions are from industry. This is a really important area that we need to focus on. And 68% of energy use in industrial facilities is from process heating. So an area very ripe for work. So we gotta electrify everything. Let's do it. The challenge is if we throw in an electric boiler for a 24/7 process, we're gonna run into some challenges. Some of those challenges are gonna be based on that 24-hour operation and the energy tariffs that they're working on. So they're gonna hit demand charges. They're gonna hit expensive time of use rates. They're gonna use electricity when the grid is really dirty, and we don't probably wanna use more electricity at that point. And it's gonna add stress to the grid. And we're talking about data centers and everything else adding more load to the grid. It's gonna create some challenges. But really fundamentally, the challenge is that retail electricity is expensive and natural gas is cheap. And so we gotta get a way to use cheaper electricity, avoid taxing the grid, and avoiding demand charges to get to a place where we can electrify this in a real way. So we're gonna use our duck curve. Our duck curve is gonna show up because we have a lot of solar showing up in California. That's reducing the amount of fossil fuel energy that's being required to meet load during solar hours. The duck curve is gonna show up in a bunch of other places here too. It's gonna show up in our pricing. And so duck curve has made a nice little nest here in Texas where you can see the pricing in the midday hours when solar is running, really, really cheap. And that's really great. Additionally, when we see this, this is the greenest part, the most renewable time of the day to be using electricity. So we want to maximize our usage during this time and avoid times when we're taxing the grid or using dirtier electricity. So when we think about this and we look at the numbers here, if we go from a 24/7 operation, that's going to cost us about $49 per megawatt hour to a 4-hour of everyday operation, that's $12 per megawatt hour. We can reduce our electricity wholesale prices by 75%. And so what are we gonna do with that cheap electricity? We are gonna heat up some rocks. We are gonna take these rocks up to 2,700 degrees Fahrenheit. And if we do that in 4 hours, we'll have enough energy to store for the remaining 20 hours of the day. And so as I said, when a toaster really loves a brick, things happen. And it gets hot. Apologize for the graphic nature of this talk. But we've now taken the electricity side, we've heated up a lot of rocks, and now we can make steam. We put water in, we blow it over with really, 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 really hot air, and we get a lot of steam out on the other side. And this steam can be used in processes just as it was before. The round trip heat efficiency is claiming to be up to 98%. For some of these technologies, and it's a plug-and-play system, which is really important when your steam system looks like this. You don't want to be touching that. We can also make electricity. If we've got high enough pressure steam, we can run that back through a turbine, and just like a CHP plant, or we can use thermophotovoltaics to make electricity. The round-trip efficiency is pretty bad, but if we use the heat as well, it's really great. The challenges are we're really in the early adoption phase. We've got a couple sort of pilot projects, but the DOE just funded 3 early commercialization projects for this process, and we're really going to make a lot of progress here, I think, very quickly. The other challenge is that we need a really much larger electrical system to support this. We've got a 6x size some of these electrical distribution systems to support this heating process. So very much dependent on where you are on the grid and if you can get support from your infrastructure systems to do that. Altogether, what the opportunity of this is to also support renewables. We have a lot of curtailed electricity already. It's going to grow as we expand and increase renewables on the grid. So if we can use that curtailed energy, that's great, and it's going to support more and more renewable development. And it's also going to increase the prices that those renewable plants get. Because if you think about it, $12 a megawatt hour is probably not going to end up with a lot of solar projects being supported by developers. There's just not enough money there. But if we can support that with higher prices, we can get two birds with one stone, decarbonizing industry and supporting renewable energy on the grid.
Thank you, Blair. There is so much to unpack here. So I'm a utility guy, and we're working right now on using the vehicle batteries to soak up the solar in the middle of the day or early morning for excess wind. But to see these prices is really interesting, that you can save 4x by doing that. So the other part is, I think probably 25 years ago, the utilities wanted a flat load, and they loved it, and they gave low prices to industrial facilities who could go 24/7. And now we're seeing this major shift. So over 50% of new utility scale supply in 2023 was solar out of the whole country. Think about that. Think about the difference between 2023 and 2017 when it was wind, and 7 years prior it was natural gas. So there's so much going on in this industry right now. It's just absolutely fascinating, and I need to get your slides too to use when I'm going to go talk to the Peak Load Management Alliance in a couple weeks, because that's great stuff. A couple questions. 2,700 degrees, is that Fahrenheit? And then the guy was holding the brick, and why didn't his hands melt?
Those are pre-hot bricks. They get hotter.
Yeah, it's I just don't think that's true. So but great.